Arrays are fundamental data structures in any programming language. At first sight, arrays are similar to lists. They represent objects, and the objects in an array are called array elements. The main difference between an array and a list is that all the array elements must be the same data type. For instance, they should all be integers or floats. The situation with lists is different. A list may contain an integer, a string, another string, and so on. Okay, perfect. Now that we know what an array is, let's create one and explain its main features. The first thing we will do is import NumPy, as this is the library for scientific computing. You will often encounter the convention NP, which is simply an abbreviation. Let's use it here. Good. Now, I will assign a NumPy array to the variable a. Within parentheses, I will place a list of lists. The first one will be composed of the values 0, 1, 2, and 3. And the other list will contain 4, 5, 6, and 7. Let's look at A now. Apparently, A is an array in which the two lists are shown one above the other. Great! Pay attention to the fact that the NumPy n-dimensional array type is referred to as an ND-ray, and it is always homogeneous. This means all blocks should be of the same data type and interpreted in the same way. For instance, if I put John in the place of 1 in the first block, an indication there is something wrong with the data type will pop up. The same will happen if I delete the block. See? So, your job will be to organize your arrays with the same number of elements and to ensure these elements are of the same data type. Let's restore the previous selection of values. Okay, good. To help you internalize the syntax we just used, consider that array is a function. The structure is identical to the one for methods from a certain class. But here, NumPy is not just a class, it is something bigger. A whole package of several modules, and each containing classes on their own. np.array is the way to apply the array function. It takes a few lists as arguments and returns a data structure in the NumPy array format. Fantastic! To see the shape of the array, just type a.shape and you will obtain a tuple indicating the object has 2 rows and 4 columns. Ignore the L characters after the digits. They simply refer to the data type of the obtained values, which is long. Nice! And how can we access one of the values in an array? I'm sure you know the answer. In brackets, type the number of the row and then the number of the column. Count from 0 in both cases. So, A brackets 1 and 3 will return 7. Exactly. Perfect. You know how to change a value in an array. Designate the position of the value you would like to substitute, say 1 and 2, corresponding to the value of 6, and, after the equal sign, type the new value, say 8. Perfect. The second row of our array becomes 4, 5, 8, and 7. Last, what do you think will be the result if you pass a single value within the brackets? What will A0 do? This will extract the 0 row for you. And A1? Index 1 row. Wonderful! Okay, probably you are wondering why arrays are so important and how they can help us when analyzing financial data. Well, array is the data structure that will carry and organize values into vectors, matrices, and other multidimensional objects. Let's make a quick reference to mathematics. A vector is an object that has both a magnitude and direction, right? So, on a Cartesian plane, the vector b of 3 and 5 will be this line. In Python, this vector can be written as a NumPy array of a single list with elements 3 and 5. A one-dimensional array is also called a vector. Following the same logic, a two-dimensional array is called a matrix. Matrices are the linear algebra term that financiers use in almost every calculation, and they cannot live without them. Mathematically speaking, a matrix is a two-dimensional representation of data to which many powerful mathematical operations can be applied. I am talking about summation, subtraction, multiplication, transposing, and so on. These features let you manipulate data, and the NumPy array is the Pythonic tool that allows you to do that. Lovely! If the concept of arrays seems slightly vague, don't worry, as in the next lessons, we will go through it often. Actually, by the end of the course, working with matrices will seem like a piece of cake to you.